Good morning, or appropriate greeting for the time of day for anyone listening to the recording. Hello, my name is Fiona, and I'm a developer and also a consultant with a company called ThoughtWorks. And today I'm really excited to be speaking with all of you about the social implications of bias in machine learning. So there were quite a few words there, and I don't think we can really go forward without first defining them and making sure that we all have a shared understanding. So I want to first clarify just one thing about bias. So what I'm talking about in this talk when I talk about bias is social bias. And I want to call that out as being that rather than statistical bias. The reason I feel this is an important distinction is because statistical bias is something we read a lot about when we're doing things about statistics or machine learning. And it's also really important, but that's not the thing that I want to discuss today. What I really want to discuss is prejudice, whether that's conscious or unconscious, some negative thought process about a group of people based on a protected attribute like race or age or gender. And that's what I'm focusing on here. So statistical bias, that thing which I'm not talking about, I'll just quickly define that as well. So if we need a value that represents something, and so we take a lot of different measurements and we average them out, whatever that is compared to the thing we were actually trying to measure, that's statistical bias or an example of it. But yeah, that's not the thing I'm trying to focus on here. Which is kind of cool, because that means that this is going to be a discussion about the human condition and not a talk about, maths. Now, I don't want to claim that bias is some horrendous thing that we just need to completely remove from everything, because actually it's kind of useful. The world is full of way too much information for individuals to comprehend and to do anything with, and we need to take shortcuts, and sometimes we need to make assumptions and generalizations just to get us through our day. The time when this is problematic is when it's reinforcing something negative that we don't want to reinforce, when we take a shortcut that accidentally removes important information. And so that's the part that I want to really focus on. The other word, which is words that are worth defining here, is machine learning. So this is the definition I'm using for this talk. I just want to get an idea, who here is working day to day with machine learning? Cool, great. We've got like 8 or so people. Awesome. And who feels they already really fully understand what machine learning is? Like, they get it. Great, a really honest audience, like a third. Cool. Perfect. So in terms of this talk, at least, I'm using these terms algorithm and statistical model basically interchangeably. I'm just going to use them as if they're the same. And what I'm really talking about is computer systems that are used to perform specific tasks. So I'm not going to talk about things like generalized AI, because that would just be too broad. And I'm also talking about systems that work without explicit instruction. So not a bunch of if-else statements just dressed up as ML. What I'm talking about is actual things based on patterns and inference. So let's have just a couple of examples to make this a bit clearer. So some of the ingredients we might have to some kind of machine learning product would be, we've got a question that we want to have an answer to. We have some data that in some way relates to that question. And then we'll take the majority of that data and train a model. We'll use the remaining data to test to see if the model actually answered the question properly. For example, we want to know, what's the likelihood of us actually hiring this candidate? So we have a bunch of information about people we've hired in the past, information about those candidates, what was their resume, their experience. And then we would take this and try and work out some correlation between those things to see what was it about that person that made them hireable, that made them a success within that organization, and then see if that was actually the case. A different example with image recognition. These are pictures of cats. I took these pictures, and to find them for this talk, I was on my Google Photos library, just endlessly scrolling, looking for cats, and I was thinking about all those experiences I've had of cats, like they're usually indoors, they're very fluffy, they have this many limbs, all of that kind of stuff. And I was trying to identify these pictures, but it got really tedious and I was bored, so I just typed cats into the search bar. And immediately Google Photos comes up with this. But the algorithm that Google used hasn't met any cats. It can't use all of those memories and historical contexts of cats in order to do that. I can only guess, but I imagine it looks something like this, the way that algorithm works. So it would have been fed a bunch of pictures of cats and a bunch of pictures of not cats, and it would have eventually worked out a way to say, okay, this one's a cat and this one's not. But what's kind of creepy and also cool about this is that if I spoke to someone from the team at Google who made this algorithm, they probably couldn't tell you in that like third level of processing, the second pixel from the left, how much does that impact this being classified as a cat? Most likely they don't know, but they know it tests well. It shows cats and not cats. And this is sort of some of the power, this black box which comes from the complexity that we get from using something we couldn't have envisioned ourselves. Something that relies on too much data for us to keep in our head. Something that uses inferences that we hadn't imagined. That's in some ways super powerful, but it can also lead to this kind of trade-off. And it's not exactly this direct, but we do have a lot more observability from simpler models that we can replicate ourselves and test on paper than we do with other ones that we really don't fully grasp. And so we can sometimes have this kind of trade-off, or at least it feels that way. All right, so how's this talk going to go down? Well, I would like to take you on a journey through several phases, starting from data collection, through the processing, the generation of a model, and eventually how that model becomes a product that's used in the world. And I know that that's a lot of stuff, so we should probably get started. From each of those steps, I want to give real-world examples. I want to highlight some risks, and also I hope to show some real tools that can actually be used to help with these problems. And at the very end, I promise, there will be a link that you can take a photo of that shows you all of the references that I've used and the links to everything that you might want. So don't worry too much if I go through a slide too quick and you don't get to see something, because it'll all be there as well. Great, let's go. So let's start where everything starts, which is with the collection of data. It can sometimes be too easy. We think about that huge lake of data we have back at the office and we think, yeah, we'll just use that. It's already there, let's go. But I'd like to caution against this. Because that data that we already have, we don't know how it was collected and whether it was really collected with the question that we had in mind. And since it's so crucial to what we're about to create, it's really worth considering that. To start off, I'd like to share a story about something that happened in Boston. So Boston, the city, they had this problem with there being lots of potholes. And they weren't sure which pothole to fix first, which ones were more important to repair, because there were so many they didn't have data about where they were and how much they were impacting the people. So like any modern city, they created an app. And the app was kind of cool. It used the accelerometer in the phone to tell if a pothole was reached, and it used the GPS to say where it was located. Cool. And then they found a bunch of potholes, which was excellent. But they were scratching their heads wondering, why are all of the potholes in like really rich suburbs? That just doesn't seem like what they expected. And it wasn't until they installed the same app on public buses and on garbage trucks that suddenly all these other potholes were discovered. And it was because it was only the people who had their own private vehicle with a spare seat, with a modern phone, plenty of battery, a lot of concern for collecting data for their local government, who were putting this phone in the car. And those were the people who they were finding the potholes with. So it really mattered who the collector was. Because as much as we say the data speaks for itself, it really doesn't. It just echoes its collectors. Another example of this. If I was to ask you about your earnings, but I did so as the tax office, or I did so as someone who you're on a second date with, or if I did so as your friend who you know is going through financial hardship. The way you express that same figure might be a little bit different depending on who of those three people I am at the time. I think this is a great quote on this topic. The fact that raw data is both an oxymoron and a bad idea. We really need to cook the data with care. If we know it's not going to be raw, let's at least be intentional about how it's not raw. So in ML, we often hear this phrase, garbage in, garbage out. But I think it could be extended to bias in, bias out. Now, I promised some tools to help with this as well. So one is this canvas. So this is the Data Ethics Canvas by Open Data Institute. And it's got, probably can't read them from here, but you can look it up later. It's got a bunch of different questions that you can ask yourself or you can ask in your team about how data is collected, how it's used, how it impacts people. So a couple I want to call out. There's one that talks about the negative effects on people. And it specifically looks at, could this data, the way it's collected and used, cause harm? Could it be used to target people, to prejudice against them? Could it restrict access to people? Or could it be perceived to do any of these things? Because sometimes perceptions really are reality. They have another set of questions about minimizing negative impact, which mostly focus around how can we measure the impact that we are having so that we can pivot if we discover what we're doing is harmless or harmful. So first, I talked about how all data is biased, so we need to be really careful when we're collecting it, and also being skeptical of whatever the data is that we already have, that stuff that we ourselves didn't collect with the same question in mind. And I suggested a few tools. The other one is the Ethical OS toolkit. It's kind of similar to the previous one, a bunch of really useful questions that we can ask in our teams. So next, we've got this huge amount of data. We've collected it ourselves. We were really intentional about it. But maybe we need to filter some of it and throw it away. Wait a minute, that sounds ridiculous. What are you talking about? Surely more data is better, right? You get better results the more you have. I'd like to question that. Let me start with an example. So historically, like hundreds of years ago, it was mostly men who were in orchestras. And this made perfect sense. It was men who had access to education and ample leisure time to learn instruments, so it was mostly going to be them represented on stage playing instruments. But as the years went by and education and leisure time became something that was much more available to women as well, for some reason, audition-only orchestras still had this problem with their gender diversity. And people wondered why. And one great orchestra decided, let's put up the curtain when we're doing the auditions. Let's make it that we take away the visual data so that no one knows the gender of the person who's playing the instrument. That'll fix it. Problem solved. Unfortunately, it didn't fix it. They still had a huge lack of diversity and they wondered why. So the next thing they did, can anyone guess? They asked the musicians to remove their shoes. Because it was the clip, clap of the heels that somehow in the subconscious mind of the people making the decision told them the gender of the person. And then suddenly women could play instruments. It was amazing. And that's when they really got the appropriate musician, the person who played their music better. And it wasn't until then that they had that accuracy. So sometimes we can actually remove the data we have less, and get better accuracy. It's just one example. So in my home country of Australia, all of these terms have been legislated as being not legally allowed to be used in any decision about someone's occupation. So if I'm hiring or firing or promoting someone, I can't legally do it based on these attributes. They're known as the protected attributes. And there are similar laws in my now country of residence, Germany, and most EU countries seem to have a version of this, where they say none of these should be used to make those decisions. And that's great when you have someone who follows these laws as a recruiter. But what about if we're writing software that helps us with recruiting? What about that original example of ML when I talked about using resumes and past hiring? In some ways, we have this really powerful ability to exclude data from a model altogether. Whereas we can ask someone, please just don't think about the purple elephant. That's really difficult. We can tell a machine nothing about the purple elephant, they don't know it exists. So in some way, this is even more powerful because we can really have this granular ability to filter out data that we don't want in our decision making. So as hard as it is to have a less impressive number of terabytes of data to use, sometimes we just need to let that stuff go because we'll get better results. So there's sometimes legal constraints that would control what we can and can't use out of our data sets. Sometimes we can reduce the data to increase the accuracy, like with the curtain, removing the visual, and then later on with the shoes, removing the audio. And though forgetting is really quite difficult for humans, it's super easy for machines, sometimes too easy. The last part about data is this third part about adding the data that is missing. Now, surely if when we measured something we didn't see this thing, it must not exist. How can some data be missing if we were really careful when we collected it? Unfortunately, it is possible, especially with trends, where if something more recent than something older might be more relevant. If we're trying to make a prediction about the future, it might not make sense to weigh all of what we've seen in the past equally, but maybe some examples will help. So when we're raising children, let's say our child is sick and we're going to take them to the doctor. We probably wouldn't now say, let's go, honey, to the doctor, let's see what he thinks. Unless we were talking about a specific male doctor, we would probably say, let's go to the doctor and see what they think. Because we as parents don't want to tell our daughter that she couldn't one day be a doctor. And we don't want the confusion when we show up at the doctor and they go by a different set of pronouns. So we would usually use these kinds of terms when we raise people. And I think it should be similar when we raise machines. I have an example from Google Translate, and you can play along if you like. This is my avatar in the top right. So what I did was I picked the language Malay. And I picked this language intentionally because Malay has this really cool set of words that say, they are. And it's not talking about maybe a group of people, it's talking about one individual. They are something. So I picked some occupations. They are a doctor, for instance, is the first one. And then I translated it into English, and based on its inclusion in this talk, you can kind of guess where this is going. Does anyone want to guess any of these? Maybe in your head. Have a bit of a think. Yeah? Go ahead. Yeah, the first one, he is a doctor, correct. And there's a few others there as well. And I thought this was totally understandable. Because let's say I was tasked with the job of building an algorithm that can do this translation. Well, what would I do? I would get all of the data that I have, everything I've got in Malay and everything that I've got in English, and I would throw it at my model generation, I would tweak some stuff, and I would end up with this. This would totally be the first, if I was very lucky, this would be the first edition. And it would probably do this because I'm sure most of the text I could find would have examples of him being a doctor and of her being a nurse. That's just what I would discover. But then the trick would be to look at it and realize the problem. Because this is definitely based on patterns in history that we don't want to reinforce. What I'm really happy about is since I first started talking about this, Google started improving this for a few languages, one by one. And so now if I did the same thing in Turkish, which again has this same they are, it will give me 2 options, which is much better. It still doesn't work for Malay, but hopefully soon. And they even have released some information saying that they plan to make this work beyond the gender binary as well, which is great. But this really required the addition of more data to get accurate results, because gender parity with doctors is already happening. And if we just look at all of the data we've had from forever, we're not going to get accurate translations. They won't speak to the current society, nor will they speak to the actual definitions of the words. So I'd like to introduce somebody. Her name is Joy, and she started this group called the Algorithmic Justice League. Joy is a researcher with MIT Media Lab, and she did her her master's thesis on looking at facial recognition software and how well it works based on somebody's race or based on their gender. What she found was that Face++, as well as IBM and Microsoft's equivalent offerings, they were not anywhere near as good at recognizing faces of women of color. The thing that really inspired her to do this research was that she was working on an art project which used facial recognition software. And I'd like to share with you her experiences. Okay, I don't have sound, but thank you.
The system I was using worked well on my lighter-skinned friend's face, but when it came to detecting my face, it didn't do so well, until I put on a white mask.
So I think this is a really good example of a product that wasn't fit for purpose because of the data that was missing. It being a facial recognition software and that being a face. Something that Joy really recommends in her advocacy work is diversity in teams. She says that this really helps in noticing the people who are missing from the picture, the people who weren't included in the data set or in the user set. And I don't think we really needed more arguments for this. There was already plenty of research saying that we get better financial returns and we get better decision making. But in case we needed one more reason, here's another one. But if for some reason that's impossible, can we at least consider our users as a more diverse and representative group, or those who are going to be impacted by our software? One cool tool for this recently made it onto the ThoughtWorks technology radar, and it's this one, the Tarot Cards of Tech. I want to pick one card in particular and call it out. It's called the Forgotten. So this card asks us some questions that try and encourage us to think about who haven't we considered when building this product. I really like the question, who would have left this product a 1-star review and why? If we think about Joy and we think about what her review would be of that facial recognition software, maybe we can avoid it even happening in the first place. Another cool tool is Facets and Facets Dive, which is by Google's PAIR initiative, their People plus AI research group. And this helps in showing who is really well represented in the data that we have. And then we can compare that with who we consider to be impacted by our algorithms and see if it really matches. So this is the UCI census income dataset, just for an example, and it really well represents a particular group. So we can see by these graphs, it really has a lot of data about professional white married men, which is cool. If we plan to make some predictions about that group, it's probably going to do a really good job. But if we wanted to extend that out to a wider group of people that we could make predictions about, then we can see exactly here where the data that's missing, that needs to be added is, and we can go out and seek that data. So sometimes we might not create something fit for purpose unless we seek out that missing data. Diverse teams are one way, or at least a diverse view of who our users are. And we can use Google PAIR's tools for this as well. But unfortunately, both require us to upload data sets, so it's up to you. I think we can't really talk about this topic without also talking about what I brought up earlier between observability and accuracy. Unless we can really observe something, how can we know how it works and whether it works for the reasons that we expect? So the GDPR, that happened, and as much as it was really cool from a cookies perspective, it also had some really interesting stuff for the ML side of things as well. As a part of this legislation, there was something called the right to an explanation. And I'm going to show you that piece of legislation now. So what it states is that the data subject has the right to know about the existence of automated decision making, which is great. I think I would want to know if a decision was being made about me like that. But it doesn't just stop there. It says we also need to be able to give some kind of meaningful information about how that decision was made, something about the logic involved. And this is huge. This means we have to open that black box. We have to be able to provide some kind of explainability. And it goes on, it says, no, we also need to be able to say, what are the envisioned consequences of this decision? I think this is tremendous because of what it encourages us to have to do in our own products. So we need to somehow open the black box. And we ideally don't want to do this by having just much simpler algorithms that we can understand, or going back to trying to do this ourselves. Because if we're getting great accuracy, let's use it. And I would argue that we don't just want to do this for legislation purposes. Not just because our government told us to and said that they would, punish us if we didn't. I think we want to do this for ourselves as well. Because it's like, if you can remember a time when you had to fix a bug, and you don't really know what was wrong or what it was about your fix that fixed it, but now it works, so it must be fine. Did you really fix it? Probably not. And so if we don't really know what it was about our algorithm that makes it able to identify cats, maybe it doesn't really do it for the right reasons. This is where LIME comes in. So LIME stands for Local Interpretable Model Agnostic Explanations. Whoa, that's a huge mouthful. But what it really means, starting from the bottom, is it gives us some kind of explanation, regardless of what type of model we've got. So do we have a random forest? Do we have an SVM? Do we have a neural network? Doesn't matter. This will still work. And it will give us something we can interpret, which specifically points out the local spot where a decision was made. Maybe an example is better. So the example that LIME used themselves is they say this has a p-value of 0.54 of being a picture of a tree frog. Cool. But why? So what LIME does is it generates hundreds of thousands of alternate images, all of which just have some of the pixels switched off. And it throws them through the algorithm as well and sees what are the likelihoods of them being tree frogs. So then you get this idea of what exact part of this picture gave us that outcome. And this doesn't just work for images. As I said, you could have a data set of key value pairs and we just remove some of those and see what the algorithm thinks. And this would give us a great idea of what was it about that data set that gave us that result. If that's too much coding, and I admit it is Python code, then maybe the what if tool is better. This is in browser. So you can, again, upload a data set, but then see what happens if you change and tweak what data you provide to your model. In some ways, I think this is super powerful. Because if you ask a person, why did you make that decision? They might be able to tell you something, but is that really the reason? Even when we ask ourselves why we made a decision, how do we know it's not just a post hoc justification? We really don't. So if we are starting to use machines to make decisions, but we can actually look and see what they did and why, in some ways that could be more powerful. So in order to trust, we need to know why, just like the bugs we sometimes fix. LIME can help us to open the black box. And there's also Google Pair's what if tool. And IBM, they have a similar implementation of LIME and a few others as well that can be quite useful. I want to quickly touch upon feedback loops. So what's a feedback loop? I guess when whatever prediction you make becomes a decision. And that decision impacts the world. And then we measure the world to get data for the next time that we want to do something. An example will help. So Facebook came under a lot of fire recently for the way that their ad platform showed ads to people. It was found that mostly women were being shown secretarial work or these kinds of traditionally feminine jobs, and people of colour were being shown a lot less really high-paid jobs. And the good thing about this platform is you can actually see who it was who saw your ad. But even though they didn't ask for this to be shown to those groups, that's who Facebook had deemed more receptive to that content. Now, how could this create a feedback loop? Well, if we have data about who we think is good at a job, and then we create a model that suggests those are the people who should be shown the ad about that job offering, and this causes a decision to be made further down the line about who ends up in the room taking the interview. And that leads to an outcome of who works in that field. And we measure that outcome in order to create data about who we think should be shown the ad. Then this will just keep reinforcing the same thing. And really, if we haven't removed the bias from our data, we've just automated the same problem. This same thing is happening in the US even today for predictive policing, for sentencing and bail determination. There's a group called ProRepublica, and what they did was they found that for this sentencing tool called Compass that determines someone's likelihood to reoffend for bail decisions, that in these two failure cases, so the case where someone is considered high risk to reoffend but doesn't reoffend, and the other failure case, the one where they're considered not likely to reoffend, but then they commit another crime. In these two cases, for white people, these were the percentages that fit into the errors. But for people of colour, it was just flipped. So there's obviously some bias in this tool, right? And yet somehow it's still being used. I know these don't total 100 because these are the failure cases, the ones you try and tweak and avoid when training a model. I really feel like this meme just says it all. I try to find a silver lining here. It's kind of difficult. But I know that juries aren't perfect either, and judges sometimes make wrong decisions. So maybe, at least if we could get observability, could we not end up with something maybe slightly better? If we can instead have some kind of feedback loop that feeds back into an encouraging direction, a direction we want to see society go, could we turn this around? I'm not sure. I'm not yet seeing it. So whatever today's outputs are of the models, they're tomorrow's inputs. We should keep this in mind. And let's be conscious of what patterns we are reinforcing versus what patterns we want to reinforce. Lastly, I want to touch upon governance and usage of these tools. So there was some really clickbaity titles in the media, I think last year, about Amazon's facial recognition software. What happened was that 28 members of the US Congress were being matched using this software to mugshots of criminals. And a spokesperson from Amazon definitely didn't like this and pointed out that this was not a valid test because the 80% confidence threshold that is the default was being used in these tests. And that's just not a high enough number. It's not a high enough certainty for these kinds of decisions about people's lives. And I agree. But this software is sold to law enforcement. And if that is the default, is that a sensible default? So fortunately, legislators came and decided to stop using this tool for this purpose. And Microsoft even asked to be regulated. When someone asks, can you please regulate me? Then you know something must be wrong. But I think we can learn from other industries. We're a baby industry, but there are other ones that have been around for ages. For instance, pharmaceuticals. If I go to the pharmacy and I buy something off the shelf, it'll tell me, what can this actually do and what are its limitations? How should I use it and when does it work? What's the actual active ingredient that makes it do its magic? It'll also tell me something to help me keep myself safe, like don't use it in these cases. Or it has this cool cap to stop my children from overdosing. And it'll be recalled. If they find out that this product is dangerous, they'll tell me to stop using it, and they'll take them back. So can we not do all of these things with software products, and especially ML? Because really, as much as it seems like it's a logical machine, it's ones and zeros, it can't make mathematical mistakes, it was still built by humans, and we are totally fallible. But this is something our users forget. Someone I think did a really good job of this recently is the organization OpenAI. Now, normally, as their name suggests, they do some AI and then they open it up. But in this case, they didn't. What they discovered was a way to make text that's really believable, as if a human had written it. And they saw this, especially when joined with something like deep fakes, as deeply problematic. And so instead, they released only a very small cut-down version of it, and then they said, actually, we want to start a conversation about this and talk about the risks. And I think that's great. Even if we accidentally release something that turns out to be dangerous, hopefully we're measuring it, and we have this huge power as the IT industry to push updates, like quickly. We don't have to recall a whole product. We can actually fix it remotely, and this is a huge power. So can we inform, restrict, and warn our users when necessary? We can all demand better products, both as people who use them and also as technologists. And unlike with humans, we can quickly update things. The physical world is much harder to update than the digital one. To summarize, let's be careful about the way that we collect data, remembering that it is all biased and not just find potholes in rich neighborhoods. Let's be intentional about what data we do show our models so that we can use this to our advantage and close the curtain and take off the shoes in more industries. Let's also remember how much diverse teams can help us to see who's missing from the picture so that we don't say that he's a doctor and that we see Joy's face. Let's use tools like Lime to open the box and really understand what it is that we've built. Let's be careful about the feedback loops that we reinforce with our products so that they are ones that match what we want to reinforce. Let's learn from other industries about how they have made mistakes that were embarrassing and not make them ourselves by being open about the capabilities of our products and how they work. Because as technologists in the room, we have an immense power to change society, and we are already doing it. And I just really hope that now and into the future we can do this for the better. I'm happy to take questions afterwards, because I don't think there's enough time, but thank you so much for coming. Here's the references I mentioned.